Hi everyone, I'm Miss Vu and today we're going to be looking at something I use quite a bit, scale drawings. I use scale drawings when I'm designing a cake, for instance. So if you've seen any of my cakes, sometimes I sketch them on a piece of paper and I have to scale it up to the real size. Or if you've seen my chalk drawings in front of my yard, I've looked at the pictures from my phone, I've Googled them for ideas and I've scaled it up to fit my whole front yard. So scaling and ratios is something that's very useful. You might see scale drawings when you look at the newspaper and looking at information, or when you read a map. There's a scale factor down in that corner over there, and it's there so that you know that this distance translates to be a much bigger distance. Or maybe perhaps your parents have bought a new house and there's a map of the house. Understanding the scale and the ratio, you can figure out which room is the biggest so that you can hold the biggest bedroom. Or looking at designs of cars or furniture or buildings, all these things require accurate ratios so that they can be made in the right proportions. Let's do a little recap to ratios. We had 1.5 to 1, or a number to 1 last lesson, and we called the 1.5 the scale factor and the whole thing, 1.5 to 1, as a unit ratio. If you don't remember that, or if you've forgotten or you haven't seen it at all, you can click on the little I in the corner and it'll take you back to that lesson. Today we're going to be talking about scale drawings, and I want to recap the words above because they sound a bit similar. Now the ratio last time was unit ratio because it was something to a unit or something to 1. Today the scale drawings have ratios that is 1 to something else. But these also have a big number, and the big number has the same name, scale factor. And we use the scale factor to multiply to get the bigger version of something, or to divide to find a smaller version of something. And the whole thing is not called unit ratio because it's not something to 1. The whole thing is called a scale ratio. So be very careful that in scale drawings we're using scale ratios, and when we talk about ratios that end with a 1 on the right side, they're called unit ratios. In both cases, we always use the simplest ratio and we omit any units. So with scale drawings, with the scale factor and the scale ratio, we use the scale factor to go from the diagram length to the real length. So the picture on my phone to the front yard, for example, or the map to real life walking. So the diagram is usually smaller. So to get to the real length, would you multiply or divide by 200? You would multiply by 200. So you'd multiply by the scale factor. And whenever you go from the real or the bigger to the smaller, then we are dividing by the scale factor. Let's do a few examples. Example 1. A real horse is 1.8 meters high. A statue of the horse is 3 meters high. What is the ratio of the height of the horse to the height of the statue? So the height of the horse to the height of the statue. So we have 1.8 meters high as the height of the real horse and 3 meters high as the height of the statue. So we write 1.8 to 3 meters. Now we have to get rid of the decimal point first, so we multiply both sides by 10 to get 18 and 30. And what goes in 18 and 30? 6 goes into 18 and 30, so we can divide both sides by 6 to get 3 to 5. So the ratio of the height of the horse to the height of the statue is 3 to 5. Let's do another example. We have the distance between two towns on a map to be 5 centimeters. So on a piece of paper, it's 5 centimeters. If the real distance between the two towns is 25 kilometers, what is the scale of the map? So we write it out, 5 centimeters and 25 kilometers. And then we have to convert to the same units. And we always pick the smaller unit because it helps eliminate any decimals. So now instead of writing 25 kilometers, we're going to convert that into centimeters. How do we do that? Well, 25 kilometers to meters is times 1,000. And from meters to centimeters, it's times another 100. So then we would get 5 to 2,500,000. And we can see that they're both divisible by 5, so we can divide both sides by 5. So then we would get 1 to 500,000. So that's our scale factor. Let's do another example. The tallest building in the world the one in Dubai, is 828 meters tall. A model of the building is made using the ratio 1 to 5,000. How high is the model in centimeters? So the model, the little one. So let's underline the important information. So we can see that the scale factor is 5,000. And we're going from 8 to 8 meters tall, the big one, and we want to look for the little centimeter scale model. Now we are using meters. So 828 meters, we're dividing by the scale factor to get to our model. So 828 divided by 5,000 would give us 0.1656. And remember, that was in meters. And the question is asking for centimeters. So we have to multiply by 100 and we get 16.56 centimeters. One last example. Here we have a map and we want to figure out how far is Smuggler's Cove, which is the first dot up there on the left, to Looters Lookout, which is the one right underneath the scale factor of 1 to 10,000. How far is the real distance? So we would measure it with a ruler and see that it's 6 centimeters, and then 6 centimeters, and we will have to multiply by the scale factor of 10,000. So now we get 60,000 centimeters. Of course, if we're looking at a map, we're going to use meters or kilometers. So to convert that to meters, we divide by 100, which gives us 600 meters. That's it from me today. I hope that was useful. Thank you for watching and see you next time. Bye!